Hi, my name is Philip Blume. I'm also known as Glum Hippo in certain circles, and I'm here to do a walkthrough of one of my puzzles, namely a puzzle called XY Differences 3. And the reason it's called XY Differences 3 is because it's the third in a series of puzzles that I made using the same rule set. The rules themselves are very simple. I'll just read them. If there's a symbol between two horizontally adjacent cells and the absolute value of their difference is the same as the first digit in that row. And first digit, I mean leftmost digit. If there's a rotated symbol between two vertically adjacent cells, then the absolute value of their difference is the same as the top digit in that column. So in the example, you can see there are 13 symbols in this 6 by 6 grid. The symbol here between row 1, column 2, and column 3 indicates that those two numbers will have a difference that's the same as the first number in the row. So indeed here you have a 1 and 4 in those two spaces in the solution, and a 3 to indicate that 4 minus 1 is in fact 3. This 5 and then these two are 5 apart. This 2 and these two are 2 apart, and these two are also 2 apart. And then vertically the same sort of thing. This 2, the 1 and 3 here have a symbol between them. They are indeed 2 apart. The 6 and 4 are indeed 2 apart. Okay, so I think the principle is fairly clear, but we're going to be doing this on a 9 by 9 grid. And here's the puzzle itself. There are a few tricks that you want to start with that really help, in fact, that make this puzzle even possible to solve. And the first of those is to recognize that that any number at the top of the row, if it's a 9, the column in which you place the 9 in the first row and the row where you place the 9 in the first column, you can't have any different symbols in there. Okay, so I think that should be pretty clear, because you can't have a difference of 9 between two numbers that are between 1 and 9. So in the first row, the 9 could be here, 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 or here. Those are all places where there are no different symbols between two vertically adjacent cells. That's a lot of options, but so maybe not terribly helpful, but certainly in the rows, you're going to have fewer options. In the bottom tier, you don't have any. In the top tier, you don't have any. It's only in the middle tier that there are two places where the 9 can go. And that's going to be the point of departure for our puzzle. We'll take these out for now. Okay, so the 9s are somewhere in here. The second trick, after you've acknowledged where 9s could go, is to recognize that if the first cell is immediately connected by this difference symbol with the second cell, we know that the first cell cannot be more than 4. Obviously, if it was a 5, this would have to be a 10. But it can be 1, 2, 3, or 4. This could be 2, 4, 6, or 8. Okay. In addition, we actually have 2 symbols in a row here, so that restricts it even more. This can't be 4 and 8, because the next one would have to be 12. So in this case, 1, 2, 3 followed by 2, 4, 6 would then further be followed by 3, 6, and 9. Okay, so we know that much about box 3. In box 1, going into box 4, we're also looking at a pair of adjacent, 3 adjacent cells, or 2 adjacent symbols, and that implies then that the first figure in this row is going to be a 1, 2, 3, or 4. This square, I call it the anchor square, because it's going to determine what's happening in the first row and in the first column, and those numbers then determine what's going to happen in all the other columns in the grid and rows in the grid. So let's go through these possibilities and see which one is actually fitting, and you'll find that there's only one way this is going to work. If this is a 1, then the 9 is going to be followed by an 8, and then it's going to be followed by possibly a 7 here or a 7 here. Now 7 isn't possible on this row, but let's not focus on that. Let's say this is 9 and this is 7. Well, the middle number is the one we want to think about. This cannot be an 8. That is because here we would have to have a 1 and 9, and then with these two additional symbols we'd have to have 1 and 9 again. That's not possible, of course. Same problem with 7. So this can't be a 1, that can only be 2, 3, or 4. The same problem with 2, because after 9 would come 7, and then 5 in some order. And 7 isn't possible either. Although we have two different symbols, two different differences of 7 that we can put in, there isn't a third one. This would have to be 3 and 10, or it'd have to be, well, various problems, 6 and -1. Okay, you get the idea. So 7 isn't possible. 6, now 6 is possible. We can have 1, 7, 2, 8, and 3, 9. However, 6 is impossible for a different reason, namely, the 9 followed by a 6 is then going to be followed by a 3. So the difference of 3 means that we're going to be repeating the 3. If this is a 3, we're going to have 2 3s in the column, which is impossible. Finally, then, the only number this can be is a 4. Let's put it in. The 4 means that this is a 5, and this is a 1 9 pair. Excuse me. This is a 1 9 pair. Okay, and that's as far as we're going to get for now with that section. The 4 then implies that this 1, 2, 3 is going to be preceded by a 5, 6, or 7. And at this stage, we can actually eliminate one of these 3 possibilities for these 4 cells, namely the middle one. This cannot be 6, 2, 4, 6, because then I'll be repeating the 6, right? 6, 2, 4, 6. Impossible. So this can only be 5 or 7. This can only be 1 or 3, 2, 6, or 3, 9. Okay, cool. The next step in this path, there are all these disconnected different symbols with which we can't make a whole lot of progress, though it's important to note that there are 2 in a row here. That means that this is 1, 2, 3, or 4. It can't be 4 anymore, remember? And it can't be 1, actually. So it's going to be a 2 or a 3. But let's just set that aside. The next thing we have to look at, though, is this pair. This pair is, at least a little bit restricted, but it's here's where we're at the stage where people might get discouraged, because in fact there are 6 different possibilities. This can be a 1, 2, and 3, followed by a 5, 6, or 7, or vice versa. Okay, so 5, 6, 7, 1, 2, 3. I'm not going to write all of those in because we're going to very quickly eliminate one of them, and then we're going to somewhat slowly eliminate the other one. But the way that we eliminate the second one is, I think, pretty cool. So the first thing we can eliminate is 3 and 7. The reason that this can't be 3, 7 and can't be 7, 3 is because the 7 is going to break either one of these columns. Now notice that this second column 2 has 2 different symbols, and column 3 has 2 different symbols. That's not the end of the world. 7 can be 2 and 9 and 1 and 8. However, in box 4, that's going to be impossible, because whether it's 2 and 9 or 1 and 8, both of those are going to break because there's already a 9 in the box, and there's already a 1 in the box. Okay, so we can eliminate 7 and 7 and 3, excuse me. 3 is linked to 7. If we eliminate 7, we have to eliminate 3. So we end up with 1, 2, 5, 6, or 5, 6, 1, 2. The next one that we'd want to eliminate now, I think, I know where we're going with this, of course. This isn't a live solve, this is a walkthrough. But I think it's logical, and I think you'll agree it's logical, that we want to first eliminate the 5, 1. The reason that we do that is because it's the one that's restricting what's happening in box 3. And there's some kind of cool logic here. I think you'll like it. So let's assume this is 5 and 1, or 1 and 5. And again, for the purposes of what we do here, the order does not matter, because we're going to be making a parity argument with this. Let's take even numbers as green, odd numbers as orange, and odd-even dominoes as blue. Okay, if these are odd, these the cells at the head of the columns, then the differences here, I've got the wrong color going on, it's got to be blue, the differences here are going to be changing parity, right? This is a 5, this can be 7 and 2, 3 and 8, 9 and 4, 6 and 1. In any case, the parities are different. And for 1, it's the same, 6 and 5, 5 and 6, and it doesn't matter whether this is 5, 1 or 1, 5. We're going to have 2 dominoes like this. Each one contains one odd number and one even number. In box 4, we've already got 3 odd numbers. So we've got a total of 5 odd numbers, which means that the 2 numbers at the top of the box here are both even, 2, 4, 6, 8. Now, with this one even and this one odd, with the 1, that means this is going to change parity. This is going to be, whoops, undo, hey, this is going to be odd. And with this odd, we're going to have 2 different scenarios for these 2 symbols. Okay, if the beginning symbol is even, then they are both odd, have the same parity. And if this one is odd, then they're going to have changing parity, namely this one is even. Okay, so that's a blue thingamajig. Okay, so realize that this is fixed as odd with these evens, and these are fixed as even. All right, so, but what's left over here? Remember that 5 and 1 is eliminating 7 and 3 from these spots. Whoops, hello, is eliminating 7 and 3. So this is 1, 2, and, whoops, sorry, it's eliminating 5 and 1. This is 7 and 3, 6, 9. Okay, so 5 and 1, 7, 3, 6, 9. The 2 odd numbers that are left here are 7 and 3 in some order. So this is either 3 or 7, and one of these is 3 or 7, here or here. We don't know. Let's take both scenarios, though. If this is 3 or 7, the difference between them is 4, so you'd have to put a 4 here. That's not possible. So instead, let's put the 3 or 7 here. Now the difference between this number and this number is going to have to be 3 or 7. And that's not possible. 7, 3, I end up with either a 10 here or a negative 4. Okay? And other way around, if this was 3 and this was 7, this number would have to be 3 away from 7, which is either 10 or 4, which repeats the 4. Okay, so the other scenario, of course, is that this this is the 3, this is a 3, 7 pair, but then the difference between them, again, is 4, and that repeats the 4. Okay? So no matter what we do, in this bottom row we're going to have a 3 and a 7, and there's no way to create a difference that doesn't repeat the 4 or create something impossible. So in a sense, we've eliminated 5 and 1 from the tops of these 2 rows, and all that's left is for those to be 2 and 6 in some order. Okay, now we can restore 5 and 1, much as we don't want to. We have to restore those. Now, with those things in place, we can take these out and again consider the parity issue. Okay, if even numbers are at the top of a column or at the beginning of a row, then they are indicating that the difference pairs underneath them are all going to be not changing parity, but the same parity. So what's underneath this 2 and 6 is either 2 odd numbers or 2 even numbers. they can't be two odd numbers, oddly enough, because the two odd numbers that are left over here are 3 and 7. And 3 and 7 are not 2 apart, they're not 6 apart, they are 4 apart. So here we can't put odd numbers at all. All 4 of these digits are even. Okay, let's actually write them in because we're going to need them there later anyway. So we've used up all the even numbers in this box, and these two, whoops, let's not even use colors because these are going to be 3 and 7. That's all that's left. Okay. With the 3 and 7 here, this is going to be odd as well because, of course, the difference is an even number so that they stay the same. This is going to be 1, 5, or 9. Okay, 2 indicates that this 3 is going to be followed by a 1 or 5. 6, I'm sorry, the 7 will be followed by 5 or 9. And the 6 means 7, 1, or 3 and 9. So this is 1, 5, or 9. Certainly an odd number. But these two numbers as well, they are going to have to be the same parity. Okay? And their parity, can it be even or odd? Well, we've already got 3 evens in the box, so both of these are going to have to be odd. Okay, let's go ahead and make them orange. There's no way to avoid that. Okay, if this is odd and this is odd, obviously, then the number at the head of the column, head of the row, excuse me, has to be even because these are the same parity. But we've got 4, 2, and 6 here already, so that number is in fact an 8. It's going to be an 8. And this then no longer can be a 5. This is a 1, 9 pair because the difference has to be 8. And this can no longer be a 9. And with that, we resolve all of the pencil marks in box 3. Why this number is blue is anybody's guess. Okay. And with that, I think we're going to take away all of the colors. Okay, now at the top of this, in the middle here, we're going to have either 3 or 7 here because 5 is already taken. 3 or 7. Can this be a 5? No, this can't be 5 because it has a difference of 4 from both 1 and 9. So this has to be 3 or 7. Let's make them both 3 or 7. And the only place for a 5 in the box is here. Okay, cool. All right, let's finish column 1 because there's a neat trick here, and this is a trick that's going to keep coming back, which is, let's see what's left over. After the 4, we're going to have 3 or 7 and 8, 1, 5, and 9. The numbers we haven't seen yet are 2 and 6. So there's certainly a 2 and a 6 in the bottom. Okay, so this is 2, 3, 6, or 7. Oops. This is 2, 3, 6, or 7. This is 2 or 3. We already established it can't be 6 or 7. And this is 2, 3, 6, or 7. Okay, there's certainly a 6 down here. There's certainly a 2 down here. And then a 3 or a 7. But 2 and 6 are 4 apart. And so they cannot be next to each other. So this is going to be a 2 or a 6. And this is going to be a 2 or a 6. And the middle number is going to have to separate them. Yeah? What did Simon say? They're going to have to play gooseberry. And the number that plays gooseberry isn't a 7, it's going to be a 3. This is 7. This is 3. And let's start pencil marking some things into row 8. With the 3 in place, we know that this sequence is either 1, 4, 7 or 2, 5, and 8. It can't be 3, 6, and 9 without repeating a 3. We saw that earlier. So this number is 1, 2, whoops. This number is 1, 2, 7, or 8. This is 4 or 5, and this is 1, 2, 7, or 8. Now these two numbers can also be 2 and 5, 5 and 8, 1 and 4, 4 and 7, or they can be 9 and 6. We really don't know. Let's leave it blank for now. But this thing, this 1, 2, 7, 8, it can't be a 2, but never mind that, because we've already got 2 in the box. This fact that we've got a 1, 2, 7, 8 is going to let us do another trick to resolve a lot of what's going on in this in the second and third column. Namely, we can figure out now whether this is 6, 2 or 2 and 6. Okay, look at the scenarios. If we put a 6 here, excuse me, if we put a 6 here, 5, this is going to be 9 and 3, or 7 and 1. This is going to be 2 and 8 in some order. Let's see, this would be 2, 3, the 3 is going to be followed by a 1, this is going to be 9, this is going to be 3. Okay, 5, 9, 3, 2, 8, 6. And the remaining numbers are 1, 4, and 7. Okay? However, 1 and 7 are 6 apart, so they cannot be in this middle square. So if this is 1, 4, and 7, we're okay. But remember what I just said, which is that this has to be 1, 2, 7, or 8. So this can't be 1, 4, 7 or 7, 4, 1. In other words, there's no way to have a 6 at the top of the column. Okay? Because there's no way to respect the lack of different symbols in box 7. So, conclusion, this is a 2. This is a 6. And these two are 6 apart, namely 2 and 8, 2 and 8. And these two are 2 apart, namely 4 and 6, 4 and 6. Now what's left over? 2, 5, 1 and 3, or 9 and 7, whatever. The 6, 3, this is going to have to be a 9. 9. This is 1. This is 7 and 3. 4 and 6 in some order, we don't know yet, whether this is 2 and 8 or whatever. But 2, 5, 1, 3, 4, 6, this is 7, 8, and 9. Okay? 7, 8, and 9, the 7 and the 9 cannot be next to each other, because 7 and 9 are 2 apart, and that would violate the negative constraint. So this must be 7. No, it must be 8, excuse me. And the two neighboring cells are 7 and 9. Okay, now we've got 1, 4, 5 here. Cool. This 8 is followed by a 5, forced. And this is a 2. Okay, and this is no longer a 5. All right, cool. All right, so that's as much as we're going to do with this first tier, and you can see we've done, this first corridor, and you can see we've done quite a lot. Now, we can do a little bit of Sudoku, a little bit of finagling here. This should be a big number. Okay. The 1 and 9 that you see here are not going to be resolved for quite a while, so let's just be patient. These two numbers are definitely 1 and 8, according to the head of the row. And if those are 1 and 8, then there's no place for an 8 in the first row except here. There must be a 9, 3, and 7 in here. Because of the 4 difference, we know that the 3 and the 7 have to be apart, and the 9 plays gooseberry. So this is 3 and 7, 3 and 7. The 9 in row 2 has to be here. It can't be here because it's 7 apart from the 2. So this is definitely a big old 9. And then these two are 4 and 6. Okay. The numbers left over in this box are 4, 6, and 7. There's already a 7 in this column, so we put a 7 here, and a 4, 6 pair here, and the 7 is followed by a 2. Whoops, a 2. Unfortunately, that 2 doesn't disambiguate anything, but there it is. It's little progress, one little bit of progress at a time. Okay. With the 7 here and the 7 here, we know that there's a 7 in the middle of box 5, row 5 of box 5. The 7, however, cannot be here because it would have to be followed by a 2, and then we've got two 2's in here. So one of these two things, one of these two cells is a 7. The 7 has to be, if the 7 is here, it would have to have a 2 in this spot, which is impossible. So the only place for a 7 really is here. Okay. Okay, and this, as you say, it's 5 apart from 4 or 6, so this is going to be either 1 or 9. Okay, and then there are numerous other possibilities beyond that, which we unfortunately can't disambiguate just yet. However, there's a very cool trick revolving around row 5, and that is that you've already got 3 different symbols in here. You've got a 4-9 pair or a 6-1 pair here, and then what's left over, 4-9, 6-1, 3-8, 2-7, 1-6, 2-7, 3-8, 4-9. We have 3 different symbols. This 4-9, there's got to be a 6-1 somewhere, and there's got to be an 8-3 somewhere, and there's got to be a 2-7 somewhere. It turns out that these 2 digits, if we have these 4 symbols in here, these 2 digits also have to be 5 apart, even though they don't have a symbol between them and they're not neighboring nodes. 4 and 9, 6 and 1, 8 and 3 are somewhere in here. This 7, its partner, 2, is going to be the other digit in the row that doesn't have a partner. Okay? So this number is, in fact, a 2. Okay? That makes this an 8, which is great, but we can't say that we're cooking with gas yet. Let's make those white again. Okay. Cool. Let's see. Now there's more work to be done in the 8th row. We have this 852 group, and then we have 2 numbers that are 3 apart, and we have 2 numbers that are not 3 apart. Okay. We have a 9 and 6 that need to go somewhere. There's no place to put them except in these last 4 cells. And then the other 2 numbers in here are either 1 and 4, or 4 and 7, or 1 and 7. Right? So if these 2 numbers absolutely have to be 3 apart, let's consider the scenario that it's either a 1 and 4. That's impossible because it means there's nothing to put in this cell. They could be 4 and 7, but then this is a 1, and I'm forcing a 9 and 6 in here. And that's not allowed because 9 and 6 are 3 apart and there's no symbol between them. Okay? And then the only thing left over here is 1 and 7 in some order, but they're not 3 apart. So you have to end up concluding that these 2 numbers are 9 and 6. There's already a 9 in this column, so this has to be a 6, this has to be a 9. And then these last 2 digits are chosen from 1, 4, and 7, but 1 and 4 and 4 and 7 are 3 apart, so these have to be 1 and 7. I'm going to put them in this order because of what's also already in the columns. That finally leaves a 4 here and no other choice. Okay, so now this is a 1-5 pair, this is a 1-5 pair. And we're going to need to do quite a bit of woodshedding here at this point. If this is a 2, this 9-7 is going to be followed by a 7 or 9. Can't be a 5, so it's either 7-9 or 9 and 7 if this is a 2. So let's write those in, either 9 or 7. If it's a 6, then the 9 or 7 is going to be followed by a 1 or a 3. Okay, so let's consider that scenario, that this is 2, and this is 7, 9, or 9, 7. That means this is 6, and these two numbers are quite restricted. What did we have? 9 and 3 have a difference of 6. 8 and 2 have a difference of 6. And 1 and 7 have a difference of 6. Okay. 9 and 3 isn't possible because the 9 is already here. 9 and 3 is possible. 8 and 2 is not possible because there's already a 2 in the box. So all that leaves is 1 and 7. Okay, that would make this a 9, and this is 7, and this would have to be a 9. And that 9 is a repeat of the 9 that's already here. Okay, so there's no way to fulfill this without causing a contradiction. So long story short, this can't be 6, this can't be 2. In other words, this has to be 6, and this has to be 2. Okay. Now, that 7 and 9 is going to be followed by a 1 or a 3. Now let's look at this pair again here. With the 2 at the head of the row, 1 and 3 are not possible because that would eliminate everything that could happen in row 7, column 4. So 2 and 4 certainly not. 3 and 5, no. 4 and 6 maybe. 6 and 4. 5 and 7, no. 6 and 8. 6 and 8. Well, yeah, let's put that in. I didn't think of that. 6 and 8. Or 7 and 9. 7 and 9 is not possible. There is already a 6 in this row somewhere. So that's cool. Let's see. 7, 9, let's see what we can put here, because this number is also fairly restricted. This can't be 3 and 9, because 9 is already in both columns. It can't be, it can be 8 and 2, but it can't be 7 and 1, because there's already a 7 and 1 in this box, so no order of 7, 1 is valid. And 2, 8 can't work because there's already an 8 in this column. So this has to be 8 and 2. And that's convenient because that eliminates an 8 from here. Okay, thank goodness. So that's a 4, 6 pair. 8, 2, 4, 6, 5, 2, 9. Okay, cool. The 8 eliminates 8s from here, so there's going to be an 8 in the bottom row. The 8 is not in this column. It's in one of these two. But notice it can't be underneath a 7 because of the difference of 1. So there's only one place left for the 8. It has to go here. And now 8 has to be in this column somewhere. 8, 8, 8. Can't be here because of the row. So 8 is in one of these two spaces. Now, what I was showing you earlier about row 5 with the many different symbols is kind of true for column 8 as well. We've got two different symbols. Yeah, this is definitely a 2. This 1 and this 8 are not 5 apart, which is lucky. But these two numbers are 5 apart. They can't be 3 and 8 because that's taken. They can't be 6 and 1 because that's taken. They can't be 7 and 2. The only thing that's left for these two boxes is 4 and 9, which eliminates the 4 from here. This becomes a 6, and this becomes a 4, and this becomes a 4. So with a 4, 9, all that's left now is 3. And the 3 is 5 apart from the one next to it, so that makes this the 8. We can't have a 9 next to the 8 here at all, So there is a 9 in the bottom box. Okay, the 8 needs to have a gooseberry between it and the 9. So the 9 is somewhere down here. We don't know where yet, but it means that this can't be a 9. This is now 4. This is 9, and what's cool is that 9 is finally going to resolve what's at the top of at the head of the box, of the row, excuse me. This is now a 1. This is a 9. Hallelujah. Cool. 2 and 7 are down here. This pair is either 4 and 9 or 6 and 1. But 9s are already taken. Yeah? So this pair has to be 6 and 1. And they are in this order. And all that's left here is 4 and 9. This gets resolved to a 6. Okay, let's see what else is left to do. 2, 4, 6, 8, 1, 5, 7, 9. And so all that's left to place in this bottom row is odd numbers. We've got a 1, 3, 7 already here, so this is going to be 5 or 9. 1, 7, 3, 5 or 9. And this 1, 3 or 7. Well, let's see. These two cannot be 2 apart. So if this is a 1, this is 5 or 9. If this is 3, this certainly can't be 3 again. Oh, this can't be a 9. Sorry, there's a 9 in the column. So this is 3 or 5. If this is 1 and this is 3, they're 2 apart. If this is 1 and this is 5, then there's nothing left for the first first pair here. So this can't possibly be a 1. There's no other place for a 1 in this row, so this, excuse me, great interface. This is 1, this is 5. If this can't be 3 anymore because it would be either the same as this one or 2 apart from it, so this must be a 7. Makes this a 9 and this is 7, and this a 1. This can't be a 5 anymore because it's 2 apart, would be 2 apart from here, so this is 3, and all that's left for this spot is a 5. And this is a 9, and this is a 3. This is disambiguated now as 3 and 7. This is an 8, this is a 1, this is a 5 if I'm not wrong, and then over here we have 6 and 4, which is lucky because none of them are 1 apart from 8. Okay, so everything is kosher here. So what's left in this column, I've got here, I'm sorry, in this row I have 2, 5, and 6. This is either 2 or 6. This is 5 or 6. This is 2 or 5. Here I've got a 1, 4, and 8 to place. This has to be a 4. This is 1. Wait, this is 4. This is 1. This is 8. This is 5. This is 2. This is 3. This is 5. This is 6. This is 2. This is 4. This is 6. And that's how to solve this puzzle. As you can see, maybe the last tenth of it is regular Sudoku. Okay. In conclusion, you can argue that what I did up here with the parity arguments for 5 and 1 is bifurcation. Sure. You can also argue that having to figure out whether this is 2 and 6 or 6 and 2 involves a bifurcation because I had to eliminate 6 by looking at the impossibilities here. Fine, but I do think that that logic is nice enough to justify maybe doing something of a deep look ahead, whether you call it bifurcation or not. Thanks for watching.